Suppose I have a power supply of 12 volts, but I want to use it to power an Arduino. In that case, I need to step down the voltage to 5 volts. Is there any way to do that? Here, I have a Zener Diode 5.6 volts. Next, I add a 1 kilo ohm resistor in series according to this circuit. Now, let's power it on and measure how much the voltage across the diode is. The measured voltage is about 5.517 volts. So how does this circuit work? Imagine it like a water tank with a hole on the side. When we pour water in, the water level gradually rises. Once it reaches the hole, it cannot rise any higher. If we keep adding more water, the excess flows out through that hole. In this way, the water level always stays stable at the height of the hole. A voltage clamping circuit using a Zener diode works in the same way. It keeps the voltage fixed at a specific value by design. The Zener diode keeps the voltage at a fixed level, but there is still some noise and ripple. To fix this, I add a capacitor, which makes the voltage smoother and more stable. When we measure again, the voltage is about 5.522 volts, slightly higher than before. This shows that the voltage has been filtered and stabilized. However, the step-down supply using a Zener diode in this way is very weak. It is only suitable as a reference voltage, not to directly power a large load. That is why we need a power transistor to amplify the current. Here I choose an NPN transistor type TIP41C. This is the symbol of an NPN transistor. It has 3 pins: collector, emitter, and base. Let's look at the diagram. First, focus on the collector and emitter pins. You can imagine this pair like an electric switch valve. When the switch is open, current can flow from C to E. When the switch is closed, current is blocked and cannot pass through CE. So we have an electric switch. But how do we control it? The answer is by using the base pin. The base, together with the emitter, forms a diode junction. It only allows current to flow from base to emitter, not the other way around. When a small current flows through BE, it is like pressing a button to open the switch. The CE path turns on. If the base emitter current is too small, the switch does not open fully, and the CE current is restricted. If the BE current is strong enough, the switch opens completely, and the CE current flows freely. In other words, with just a small current at the base, we can control a much larger current through CE. And here is the complete circuit diagram. The reference voltage from the Zener diode is fed into the base pin of the transistor. When we supply 12 volts, the voltage at the base pin is 5.6 volts. At the beginning, the output capacitor is not charged, so the voltage at the emitter pin is 0 volts. Remember, the transistor is actually controlled by a hidden diode between base and emitter. For this diode to conduct, the voltage difference needs to be about 0.7 volts. At first, since VBE is greater than 0.7 volts, current flows through the BE path, making the transistor conduct and charge the capacitor. When the capacitor charges up to about 4.9 volts, at that moment, VBE is exactly 0.7 volts. The hidden diode stops conducting, and the transistor pauses. When a load consumes power and the output voltage drops, VBE once again becomes greater than 0.7 volts. The transistor immediately conducts again, charging both the capacitor and the load. Thanks to this mechanism, the output voltage is always maintained steadily at around 5 volts. Let's solder the actual circuit. and see how it works. The measured result, the output voltage is quite accurate, around 5 volts. This voltage can easily power an Arduino. Checking the temperature, the circuit runs fine and is not too hot. Next, I test with a heavier load. A resistor of 5 ohms, so the output current is about 1 ampere. At this point, the voltage drops to 4.2 volts. Clearly not good. The reason is that the current supplied to the base pin of the transistor is not strong enough. So I replace the Zener bias resistor with a smaller value, 470 ohms, to increase the current into the base pin. After replacing, the output voltage goes back close to 5 volts. But when I check with a thermal camera, the transistor temperature rises very high, over 110 degrees Celsius. That's why, if you plan to use this circuit with heavy loads, you must attach a heatsink to the transistor. So, we have just explored and built a simple linear step-down circuit using a Zener diode and a transistor. The advantage of this circuit is that it is easy to assemble, low cost, and suitable for small loads such as an Arduino or other low-power electronic circuits. However, with larger loads, its limitation is poor efficiency and the transistor generates a lot of heat. In the next videos, I will share more efficient voltage regulation solutions, such as dedicated linear regulator ICs or switching power supplies. If you find this video helpful, don't forget to like, subscribe, and turn on the notification bell so you won't miss the upcoming content.